So let's get out of this hex dump right here. And with a clean terminal, I'm going to move this over to the side, and we will invoke the YARA binary, so YARA 32. And now the first positional argument that we want to pass in is the rule that we're going to be using. Now we're in the working directory of the YARA rule that we've just saved. And so I will type in YARA template.yara. You can, of course, tab autocomplete. Now I want to do something. The first thing that we're going to do is point this right at the file that we suspect. So the file that we suspect is malware.yara1.exe.mals. So you can, the second positional argument that you pass in is either the file that you want, and we'll start with that. And then I'm going to show you how to do this to a full directory. And then I'm going to show you how to do that recursively from any directory on the file system. So we're going to start by passing it in the YARA rule template that we're using as position 1. And the file that we suspect that we want to scan as position 2. Now, the next thing that we're going to do is pass in the -w flag, which is going to suppress warnings. And that just cleans up the output of the terminal, make it a little bit easier to read. Now, the other thing that I like to do here is -p and a number after that. And this is going to specify the threads for execution. Now, YARA is multi-threaded, so you can pass it in up to 32 threads for YARA 32. And that's going to make it a lot faster. And so we can go ahead and hit enter on this. And it turns out that our YARA example rule, which has been defined up here in the rule section, returns that there have been detections for this YARA example rule. Now, of course, we can turn this into anything that we want. Let's call this PE, you're the man now, dog, nim. And we'll save that. And we'll go ahead and run this one more time. And now our detection rule says that this rule, PE, you're the man now dog _ nim, that this malware.yara1.exe file has detection criteria. Now, let's say that we want to know exactly what criteria has triggered. Well, we can go back here to the start of these flags, and we can pass in the -s flag, and that's going to be the strings output. So any string matching for any of these criteria that is identified inside of the file that we're scanning, we can hit that. And wouldn't you know it, now we have the detection criteria, the location of the detection criteria inside of the file, and the string itself. So super powerful string matching here. And we find that at this location in the binary, we do in fact have the you're the man now dog string. We have a whole bunch of strings that identify nim. And then we do in fact have the PE magic byte of MZ at position 0. So we'll clean the terminal here. So that is how you scan a single file in YARA. But what if you wanted to scan the contents of an entire directory? Well, that's actually very simple. If you want to scan the contents of the current working directory, you would pass it in the shorthand for current working directory, which would be the dot. And so we go ahead and throw in the dot, and we do the exact same rule set, and it comes up with the same file right here. So it says, find me a portable executable that has the strings that I've determined. So here's something interesting. If we go in and we comment out this criteria that determines that the file is a portable executable, and the comment is just 2 / like that. If we comment that out and save the rule file and run the exact same rule, we will actually identify our own YARA rule as well. And that's because it's saying, find me where this string exists inside of a file. Well, the rule itself definitely has the strings, right? It has the you're the man now dog string right here. So what we need to do is put that back in to make sure that we're only getting portable executables. And this same kind of methodology can be applied to all other types of documents. You can go grab the magic byte header for a JPEG or a GIF, or maybe even a Microsoft Word, Excel document, anything like that. So if we run this one more time, we go into the current working directory with the dot, and we look at the rule template, and we find that the executable has these strings inside of it. So we have covered scanning an individual file. We have covered scanning a full directory. Of course, if you want to scan any particular directory, you can pass it the full path here. So C users Tusky desktop, and it will look in that desktop directory, and it will find you any files that match the criteria. And now the last thing that I want to show you with YARA is what I think to be the most powerful feature of YARA, and that is the -r flag. So YARA, this turns YARA from maybe like a file scanner or even a directory scanner into a full-on, what I consider to be a full-on threat hunting tool. And so -r is going to recurse from any given directory. So we can actually even roll this back all the way to the C users directory, and it will recurse into all of the user directories that are on this host. Now, it helps to have administrative access to the system that you're doing this to. When I hit go on this, you're going to see a whole bunch of error messages because I can't access some of the files on the file system, but that's okay. When I hit go on this, there's going to be a lot of output, but you're going to see that that is one of the reasons why the recursive grepping is so powerful in this YARA detection engine. And so we get a whole bunch of output here, and we see that our rules are triggering on tons of files inside of the file system. And so some of them are in chocolatey, so the package manager. We've got a whole bunch of pattern matching on these different executables. And maybe we want to throw in the -s flag again and see which strings are matching these inside of each of these files. And so we'll run this one more time. And here we go again. We have the pattern matching. We see the strings themselves, and we see where inside of the binaries that these strings are located. So if we start scrolling through the output here, we identify a whole bunch of information, and these rule criteria are triggering on lots of different things. So we see that we have our suspicious hex string, and look how we have the wildcard byte is different between some of these examples, but they're flanked on both sides by the criteria that we specified. FFE4 wildcard 00FF, FFE4 24 00FF, or FFE4 A6 00FF. And then we get other things. So we'll see that the rule is identified on the Java install cache base image fam8, and then it has a whole bunch of strings. Now, these don't necessarily indicate that this was compiled with NIM, but we do see that our string matching has returned results. So this is one of the most powerful features of YARA. And truly, if you fine-tune your rules enough, you will be able to grep through entire file systems and identify malware that contains these strings. And you'll be able to publish these, and people around the world will be able to use your rule sets to identify if malware has infected their networks. So it's just super powerful, and we see that right here at the end. We have, in fact, identified the yara.exe.mals with "You're the man now, dog" as the string. So that is YARA. In a nutshell, it is super simple to write YARA rules, as we saw in our YARA example right here, but the power of these YARA rules cannot be overstated. And YARA as a detection engine is one of the best possible tools that a defender can use to identify if malware is in the environment or not. So that's our section on YARA rules. We're going to move on to report writing, and then we are wrapping up this course, my friends. So let's go ahead and meet me in the next video. We'll talk a little bit about report writing.